triangle MNP has vertices n 2, 2 and p 0, -2. The triangle is symmetric about the y-axis. What is the approximate measure of the largest angle in the triangle? Well, this is something that requires a picture for sure. Okay, let's see. So we have 2, 2. Alright, so let's get a schematic of that. Alright, so this would be 2, 2, and that's point N. And then we have point P is 0, -2. So I got to get this going on. So point P would be right here. 0, -2. Well, the triangle is supposed to be symmetric about the y-axis. So it's got to be the same to the left and the right. Point P is right on the y-axis. So its reflection is itself, so I don't have to worry about it. So point M must be the reflection of point N. So here's point N, over here 2 units to the right. Point M must be 2 units to the left, alright, if it's going to be symmetric about the y-axis. So that means point M must be right here. Okay, so here's point M, and that is the point -2, 2. Okay, so we have this triangle, which I'm going to draw. Okay, so we have the triangle. Now, this side here at the top, we know has a length of 4. So we might as well go ahead and put that down because we know it. Alright, that's 4. Okay, so what's the approximate measure of the largest angle in the triangle? Alright, well, let's just go ahead and find the length of one of these sides. Alright, let's say if I call this n. Alright, I want to find the length of n. So I could look at it this way. There is a right triangle that sits like this, where n is the hypotenuse. Alright, the little horizontal distance right here is 2, and the vertical distance right here is 4. So I could do the Pythagorean theorem and find n. And that's going to turn out to be, so n squared is equal to 4 squared plus 2 squared. So that means that n squared is equal to 16 plus 4. N squared is equal to 20. N is equal to the square root of 20. 20 is 4 times 5. Well, I mean, we got decimals anyway, but so n is 2 radical 5. Okay, so I just found the length of a side. Now, this is isosceles. I mean, it's symmetric about the y-axis, so these two sides are the same. So I just found that this side on the left is 2 radical 5, but of course that's going to be the same over here, 2 radical 5. So now we have all 3 sides of this triangle. Okay, this is a side, side, side situation. Whenever you have side, 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 you could use the law of cosines. So that's what I'm going to do. Okay, I think I will use the law of cosines to find angle P. Alright, so the law of cosines goes like this. So it kind of starts off almost like the Pythagorean theorem. Treating this 4, pretending like it was the hypotenuse almost, we will have 4 squared is equal to, a squared plus b squared. 4 squared is equal to 2 radical 5 squared plus 2 radical 5 squared. Okay? Because the law of cosines goes basically like this. C squared is equal to a squared plus b squared minus 2ab cosine c. Alright, this is the formula. Okay, so I'm treating the 4 obviously as the c, and I'm treating the other 2 sides as the a and the b. Okay, so it's time for minus 2ab. So it's going to be minus 2 times 2 radical 5 times 2 radical 5. Messed up a little. I gotta fix it. It's going to bother me. Okay, 2 radical 5 times 2 radical 5. Okay, you know what? Now I'm mad for putting 2 radical 5. N is radical 20. Okay, rather than putting 2 radical 5 like a dummy, why didn't I just leave it radical 20? I mean, I guess I've just been trained to simplify it, but my life will actually be easier if I leave it as radical 20. Alright, so I'm going to replace all these with radical 20s, because my life will be easier. So radical 20, radical 20, radical 20, radical 20. Okay, and then cosine c. So cosine, and see here I have c, and I have side c, and I have angle c. That means they're across from each other. So if I use 4, then I have to use angle p, because they're across from each other. So that's why I'm going to do the cosine of angle p. Notice that angle p is the only variable in this whole thing, so I should be able to solve for it, no problem. Okay, so this is going to give me 16 equals. Now when you square something with a radical on it, the radical and the square cancel each other out. So this is just going to be 20 plus 20 minus 2 times. Now when you multiply a radical times itself, the number comes out. So that's going to be, in fact, let me just show this up here. Radical 20 times radical 20 is 20. Okay? So then I have 2 times 20, so I might as well go straight to 40. So minus 40 cosine p. Okay, so this is going to make 16 is equal to 40 minus 40 cosine p. Please don't think you can do 40 minus 40 and make 0 or something like that. Multiplication becomes before subtraction, PEMDAS, order of operations. So you can't combine these. Instead, you need to subtract 40 from both sides. So we get negative 24 is equal to negative 40 cosine p. So now we divide both sides by negative 40. Alright, so that's going to get cosine p by itself. Okay, so this is going to be positive, so what's 24 divided by 40? .6. So cosine p is equal to 0.6. So if I want to find angle p itself, I have to do the inverse cosine of 0.6. Okay, so inverse cosine of 0.6. So that's 53.1 degrees. Okay. All right, so we know that angle P is 53.1. Now, what about the other two? Well, let's subtract from 180 because we know they have to add up to 180. But these two have to be the same. So I'm going to subtract from 180, but then I should be able to split that evenly to find the two angles. Okay, so I'm going to do 180 minus 53.1. That leaves 126.9 to share with the other two angles. So because it will be shared equally, I will divide by 2. So that will be 63.45 or 63.5. So each of these other two angles should be 63.5-ish. Okay, so those two angles are the biggest. Okay, so I think we are shooting for this one, the 63.6. So I think the answer is the third one.